Okay, excellent. Thank you, Mike. Really appreciate it. Batting second in our lineup is Laz Keszthelyi, and I'm really sorry if I pronounced your name. Laz, are you there?
So there's a list of co-authors. Anything I got right, thank them. Everything that's wrong, blame me. We can go on to the next slide. Just wanted to say that for resource assessments, the USGS has a method. It seems to work well. We've tried to apply it to the moon, and we've shown that it doesn't make sense to use it for solar power. The problem is too deterministic. It doesn't really work for lunar ice these days because we don't know enough about the processes, and that's the first step. But Regolith is just about the right level of uncertainty that it seems useful, and we're doing a demonstration of that type of assessment right now. But today we're going to focus about sample return supports ISRU. So if you can move to the next slide. First of all, I wanted to talk about what kind of ISRU are we talking about. The emphasis, because we have a method that works well for Regolith, is on Regolith. We're interested in bulk regolith, so you can just move the dirt that's on the surface instead of bringing it from the earth for simple things like protecting from micrometeorites or giving you thermal protection. And if you pile up enough, it can provide radiation protection as well. The key thing here is to be able to move the material relatively easily, so you don't want big boulders, and you want an area that your vehicles can drive around on. And the folks at JSC have some very interesting machines for moving soil around on the surface. So there's lots of ideas here. There's an ESA illustration there of ideas of how one might use the bulk regolith. Next slide. And with a little bit more processing, you can do things like 3D printing. And there are just a couple of pictures of various folks have been trying it, and that one just happens to be the stuff that ESA has been doing recently. The key thing here is you don't want even pebble-sized particles in there. You want stuff that flows through your machinery quite easily. Particularly, it might be useful for landing pads. Next. Then the next level of processing is to actually heat it and perhaps flux it with oxygen, and or hydrogen, and then you can extract oxygen from the regolith. Again, there's demonstration things going on at ESA with NASA on the Mauna Kea field test. There's lots of things going on in this regard, and pyroclastics may be particularly good for this kind of operation. Next slide. And then, of course, there's people interested in using ice to turn into rocket fuel. And we're not in a very good place to talk about this. And there's a lot of interesting work being done, but I'll just leave it at that. Next slide. So what are we missing in terms of sampling the regolith? We have some very nice samples, and we know a lot about the processes involved. What we don't know is the vertical and lateral distribution or variations in the regolith on the scale of ISRU operations. Of course, we don't know what those operations look like right now. But there's evidence that perhaps the biggest change in parameters related to the regolith will be tied to slope. But if you want to operate on flat slopes anyway, then there may not be much variation due to that. Grain size will change with around small craters, and that will affect things laterally and with depth. And so you want to be able to start to understand what goes on around the craters right in the area you're trying to work.
1 minute remaining.
Yep, next slide. And so cores are obviously the thing you want from the regolith, but we want to tie those cores to the orbital data. So we've already heard some nice ideas about how you can have lots of different kinds of instruments on the surface to help connect the sample you're collecting and put it into the context of the orbital data. So since you've already heard a lot about that, let's go on to the next slide. The last thing you want after coring is to be able to look at the variations with depth and laterally, and that means trenching. To put it into a 3D context. And we've seen trenching. Jack Schmidt's done a wonderful job with the tools available. It would be nice if we had tools that were more specialized for making nice trenches. And the next slide just shows some textbook examples. One's literally the cover of a textbook, and the other is just a particularly nice looking poster I found online showing how good a trench can look with the right tools. Be nice to be able to do that. I think the next slide is my last slide. And for ice, yeah, there's all kinds of challenges there. I feel that we need to wait till after Viper to really know what we want to do. But the one thing I wanted to point out was if we want to do statistics, you can just barely start to do statistics with 10 samples, and 30 is really the bare minimum to understand what the population looks like. And that was my last slide.